Welcome to the SmartTechCheck podcast, hosted by Mark Vina, your home for candid, insightful, and provocative conversations about the smart home automation, security, smartphones, PC and console gaming, and much more.
Hello, everyone. My name is Mark Vina, host of the SmartTechCheck podcast. Today is Wednesday, April 19th, 2023. Reducing latency has always been a challenging problem to solve as part of maximizing the user experience, as well as being able to execute particular usage models in a sufficient manner. Specific to the self-driving and EV markets, mitigating latency is a must-have feature that literally has life and death implications. To discuss a breakthrough and disruptive new technology solution that Infineon is bringing to the market, I'm joined by Sandeep Krishnegowda, Infineon's VP of Marketing and Applications. Sandeep, welcome to the podcast.
It's a pleasure, Mark. Thank you for having me.
Oh, this is going to be an exciting topic to talk about. What I want to do is, before I get into it, because we'll be all over the place if we don't do this in an organized manner, what I want to do is talk about your background first, and then we're going to get into not only this new technology that you're bringing to market, but we're also going to discuss the usage models, what's breakthrough about it, and why it's so critical, because I think some layman mainstream folks have kind of sort of understand why reducing latency is important in a kind of a PC or Mac application manner. You know, there's new generations of PCs and Macs have come along. They're all now using solid state drives, which obviously improves latency. But we're talking about a completely different ballgame here when we talk about the technology you bring to the market. But first of all, what I want to do is let's talk a little bit about your background, because I think that's important. And I think the viewers and listeners will really appreciate hearing about your background before we get into the meat of the podcast.
Yeah, I mean, I've been working in the semiconductor industry for over 15 years. I worked on all different types of memories, embedded systems in different roles, from design, product development to marketing and different executive roles. So I started as a new college grad from Rensselaer Polytechnic Institute, New York, Troy. Did my master's there in various different roles at Cypress Semiconductors before we were acquired by Infineon in 2020. And I'm part of the Automotive division, working on the next generation NOR flash memories for automotive.
Well, you certainly have the right technical and technology background, because this is just I find this really interesting in terms of the kind of the minutia that really is important about why this new announcement is going to, I think, so critical, and it's really game-changing in many ways. So let's go right into that right off the bat. You're announcing a new product, a new solution called SEMPER X1. So why is it important to the auto industry?
So you think about what's happening today in the automotive industry, right? There are two main trends that you observe. One, you hear a lot of decarbonization, and you hear a lot about digitalization. And when you think about decarbonization, you actually see it. I mean, you see how many more electric vehicles are there out today on the roads than what used to be 5-6 years ago. And you think about digitalization. I mean, there's a lot about green mobility. There's about autonomous driving. There's about connected vehicles. What's happening with all this is, you see the future towards more self-driving vehicles, more about software-defined vehicles. Now, it's a journey, Mark. It's not something you just wake up tomorrow and say, I have everything I need to define a software-defined vehicle.
Right.
You see different OEMs, different parts of the world. You see them transitioning from an architecture that used to have many ECUs in the car, over 100 ECUs in the car, right?
Yes.
Towards far fewer in steps, and towards the software-defined vehicles. And what you see today is domain architectures. You see several different functional areas of how a car is done in a domain architecture, towards a zonal architecture, where now you have a few zones, like you have things in the front, you have things in the back, you have in the side, and you have a central ECU at the center that's monitoring and doing all the activities. So, and different OEMs are going through this transition towards software-defined vehicles, because of that's where really how transformation of the vehicle is going to happen, right? If you think about what's happening in these type of cars, especially when we talk about autonomous drive cars, right? The amount of sensors. I mean, you have cameras today, you have lidars, radars, all types of sensors. I don't know, Mark, how many cameras you have in your car, but my car, I have about 32 cameras.
No, yeah. Let me just pause you for a second. I mean, even cars today are not self-driving. Cars today, even non EVs, but even a current vintage car today, I would probably suggest over the last five years or so, these cars are driving computers, and they have all kinds of sensors for parking. There's literally, there's scores and scores of subsystems in the car, and the car is really a drive. Not only is it's a compute engine, it's a sensor-based driving engine. So you're absolutely right, and I think that analogy is exactly right.
And you see, there's more and more happening, right? There's more cameras, there's more sensor types, radars and lidars that comes in. And there has to be something evident, especially in automotive. The real-time compute performance has to be very high, right? You cannot just be like, I'm working on a laptop, right? And then you can make a decision, you can context switch your applications, and no, when there is something that's happening, something comes in front of your car, real-time decisions has to be made.
Yes.
And it has to be made in a very defined moment, very small latency. And you see that very much. There are specs around how an airbag deploys, right? Today in a car. You're not going to say, no, when an accident happens, that's the primary thing that has to get deployed first.
That's exactly right.
So that gives you an element of real-time application. And this is also happening in a self-driving car with many, many more functions associated with it. And so there's an explosion of performance needs for real-time applications that are safety critical, right? And you'll only drive a car that you trust in. And to build that trust, you need to build trust in the technology underlying to that, right? Now, let's go one step deeper, Mark. Now, how are they going to realize this type of performance? The technology that used to exist in the cars 4 or 5 years ago and even today is not sufficient, right? So they used to work on technology nodes in CMOS, 40 nanometer, 28 nanometer. Now you see the transition where processors are being built in sub 10 nanometer. So we have customers working on 5 nanometer, 7 nanometer, and even 3 nanometer. So there's lots of compute going into the car to make this technology come together. Now, when you think about compute and you hear a lot about scaling, and that's because you're also driving a vehicle that's on batteries, it's important. Power is important. So you go to a new node, and that's logical, right? You want faster performance because you have more applications to run. But there also has to be an element of, hey, it's not just about compute, what's happening on the memory side, because it's not easy. You cannot neglect the memory innovation that also has to come in to support this type of processors. So there's one key trend that I want to bring more awareness to the customers and partners of yours is when you transition the processors to very advanced technology nodes, what used to get executed on this code, you had embedded flash inside a processor in the previous generation processors, and they would execute the code inside the processor, and that was good, right? But when you're moving to advanced nodes, you see a disintegration of technology because the memory is not scaling, only the logic is scaling. So the memory is getting disintegrated and going outside. And now you need a very high performance memory that can actually work with these processors. And so that's what SEMPER X1 is about, right? So the standard NOR flash memories that we have that's in the industry today, it cannot support this transition towards a new architecture, the new processor. So we had to create what we call a new category of memory called LPDDR flash. And SEMPER X1 is a very first product, in associated with this new category of memory called LPDDR flash.
Right. So and I think that's the point that I'm glad you made it. This is something brand new. This is not a rehash of older technologies. This is really a new solution, a new approach to memory that I think is obviously critical in the usage models we've talked about. And again, I think the operative word here is real time. And I like the analogy you used about an airbag. As silly as that might sound, when you have an accident, an airbag can't deploy 3 seconds after it notices that there's a crash. That could be literally, that's really a life and death scenario. And the fact that you bring this capability together in a real-time basis with a processor chip orientation, I think is really interesting. So let's get into the technical for a second. I generally like to keep the podcast at a high level, but let's get into the technical details about this and talk about really the breakthrough component of this new capability.
Yeah, I mean, what's fundamental innovation in this, right, is the fact that we have a very high performance interface, like an LPDDR interface, to a non-volatile technology.
Mm-hmm.
The key here is to a non-volatile technology, right? You hear a lot about an LPDDR with a volatile technology like a DRAM, and you see that it's there everywhere, right? It's there in cars, it's there in our laptops, it's there in our data centers, but not with a non-volatile memory. And this is the very first product ever to be built with non-volatile technology with an LPDDR interface. We had to make some few minor tweaks to deliver the true performance because we had to optimize for latency, right? So, and we had to optimize to work with the non-volatile technology, and that's what we did. And
right.
What's important that you also notice on the screen, right, is the fact that you have more and more cores, which means there's a consolidation of applications that run on these processors. And all of these has to work in real time, and they need multiple different banks on your flash memory
right.
that don't interfere with each other, right? You don't want to be, if there is a certain real-time application running on core, then you want to have freedom of interference between these applications accessing the memory. And that's what this device does very well, and hence we did this. Now, if you look about the performance that you get, right, and I mentioned, today the technology of NOR flash, which is the Octal, the highest performance device, is not capable. And this device offers 8x the higher performance and bandwidth. So you get 8x more data, so you can run faster. But most importantly, it gives you 20x higher random transactions to the memory. 20x.
Yes, I want to underscore that. 20x. You don't typically see that in a kind of run-of-the-mill technology iteration. That's a big improvement. 20x.
This is a leap. I mean, this is a magnitude of our performance difference. And this was designed to have multiple applications that can be pipelined, to deliver that performance, right? And I go back to the analogy we used. You think about a zonal controller which has multiple cameras, multiple radars, lidars. You're running multiple applications on the zone that has to make real-time critical decisions.
Right.
And if you have a processor that does not have an embedded flash on it, you're depending on an external memory. This is what delivers that, right? And there's other ways of how customers can solve the problem, and I'm not saying this is the only way. There are ways where you could have a lot of SRAM inside the memory, but there is also, you have a DRAM, and customers can use a DRAM. The challenge with the DRAM, of course, is you have to train a DRAM interface, and that consumes about 100x more than what an LPDDR flash can do.
Right.
The DRAM is volatile in nature, which means you have to keep refreshing the data, especially as your temperature, the rated in our cases, is more than 125 degrees C rated part. So if your temperature goes up, then you're refreshing your memory cells more frequently. Mm-hmm. And that reduces the efficiency and access of your DRAM device. So in our case, that's we don't have that with a flash with an NVM technology. And these are all the benefits that architect gets when he's designing something with this new category of memory with an LPDDR flash. And that's where I think, this is the breakthrough from our perspective, to take what was already in the industry, right? It's a proven LPDDR interface is a proven technology interface, and we didn't try to reinvent the wheel there. What we did was combine a technology, a non-volatile technology that is extremely fast, gives you about 10 nanosecond accesses to this memory, to an LPDDR interface, and that is what brings something new to the market that is fantastic.
Well, one thing I do want to get into, because it's not a casual observation, is that when a company like Infineon, which has been around a long time and they've got tremendous technical chops and operational chops and all kinds of expertise in multiple product spaces, is when they put their rubber stamp on a new technology, that's a big thing, because a lot, especially in the auto space, where especially EVs that have, those cars have, MSRPs in the $60,000-$70,000 range. Yes, the prices are coming down, but they're still expensive products. And any car manufacturer is loath to embrace a brand new technology if it's going to add risk. And I think the fact that you're leveraging a proven technology out there in from an interface standpoint, I think I want you to talk about just the design-in expertise, the fact that Infineon does have a reputation for being a very strong partner with its customers, and being a partner with an auto company is not a trivial thing. So talk a little bit about that, and the fact that, again, this technology, it's not like, while it is breakthrough and it has incredible performance improvement, it's not a high risk for a company to embrace that and implement the technology, not only in the short term but long term as well.
Very good point, Mark. I think it's important to recognize that Infineon is number one in automotive. We have been in this industry working together, for over 3-4 decades. So we know what is really needed for an automotive industry. We know it's important to have a technology that's extremely reliable, that is safe, that is secure, and delivers on the performance. And so, in many aspects, what we did is work very closely with our partners, in this case, the SoC partner that is developing these processors, these real-time processors. But we also had to put this in a system environment, right? So we work, if you realize, in the automotive industry, you have a tier one, like a Bosch, Continental, the several tier ones that build these ECUs that then go to an OEM. And it's important to understand the vertical ecosystem to bring such a solution into light. And something that we did very well in firstly, being in the automotive industry, we recognized the trend and the challenge way early. So we knew exactly what's going to happen. And hence we were able to innovate together jointly, right, with a tier one partner, with an SoC partner, to actually define the solution. And we didn't just stop there. We really went much ahead in actually building a solution, putting it in an actual system, and start to develop and test to make sure that the performance that we say on paper is actually met on silicon. They're very two different things, and it takes quite a development process. And you see, many trends towards functional safety. There's new emerging regulations around how you develop products for automotive, and this is very common in the ISO 26262 standards. And developing these systems that meet certain safety levels, which they have A, B, C, and D, and something that we have done is the highest level, right? Something that is super safe, that actually can work in a powertrain type of an applications in the cars. This requires more than just building memory. Let me say it that way. There's lots of diagnostics that goes into the device. There's lots of innovation that happens as well to bring such a solution to the market.
Right. Well, again, just to close this out on this particular topic, It's just that I think Infineon's legacy and their brand and value proposition, as just not a technology provider, but as a company who really can bring things to market that has very high levels of confidence when they're working with a partner. I think that's obviously a big deal. But the thing I do want to talk about, because this is going to be I'm sure that this will be an interesting part of the podcast, is how is the industry responding so far to this? The value proposition obviously is an important element, but give us, some feedback on terms of how this is kind of, the reaction has been to it. Because this is a breakthrough. This is not something that's just an iteration enhancement. This is a totally new ball game in many ways.
Yeah. So let me be honest with you, right? It's too early at this point to say how the industry is going to respond. As I mentioned to you, what we have done is had worked with a few of our SoC partners, worked with a couple of the tier ones to bring a solution in place that now demonstrates the value, right? That a system performance. And something we need to understand, especially in an automotive industry, which is quite different than a consumer product, is that the design life cycles for automotive is in the range of 5 to 7 years. It's kind of coming down with new innovation, but it's still around 5 years. Compared to a laptop or a new consumer device, you can do that around in 1 year, and you see that refreshed every year.
Right.
That's quite different for automotive. So we've been working with our partners on this solution for the last 3 years. And once we are now at a place where we see this performance is actually realizable in a hardware, in a system, and this can actually get deployed in the new cars that will be built in the 25-26 timeframe, I think this is kind of where the excitement is, because you're now able to consolidate a lot of safety critical applications and functions into a single zone control or a domain control. And the innovation with our technology here with this LPDDR flash with SEMPER X1 enables this new car. So for me, looking at what the value proposition here for the industry, it's really about having an alternative, firstly, because of the disintegration of embedded flash that delivers on the performance. And when I mean performance, I'm referring to the real-time performance, right? Yeah. Because you are actually executing code. And you have to meet that with the safety and security aspects that will be governing the future of next generation software-defined vehicles. So
right.
That's what's new. That's what's the value proposition that we bring.
Well, and I love this slide right here because it really lays out. I mean, there's more than, I'm sure this is just kind of a Cliff Notes version of the number of functions in a car, and it obviously always expanding. But the fact that it's this kind of capabilities addressing, 20 very, very specific safety critical functions, and of course there are more than that if you really want to drill down. I think that's a big deal, and I can understand why the value proposition is so compelling. The thing that's interesting, and this is, well, we're getting close to the end of the podcast. Got to talk about this because this capability could be applied to even other categories, but this gives you an opportunity to really talk about what's next in this space and just, hey, what's coming down. If you could get that kind of Infineon crystal ball out, where do you think things are headed?
But yeah, I mean, you mentioned it, Mark, that there were 20 on the previous slide, right? But you think about there's more sensors coming in. There's more types of sensors. So there's more safety critical things that's actually growing. And so what does it mean? It means more real-time performance, right? So more real-time performance means you really need to think about, okay, it's not just what we have today, what we have. X1 stands for, hey, it's our first generation. We're already working on our second and third. So you can start seeing in aspects of there will be a growth in performance needs. And so we need to develop a roadmap. So you can expect higher performance LPDDR flash memories in the future. Mm-hmm. Second, for me, it's not just sufficient if there's one single player in the market, right? And what we do actively is as we bring these new categories of memories with the new interface and types, we actually go and standardize this in the industry. So we have more competitors that can build and customers have a choice to use more than one supplier. And that's become more and more critical, as we learned in the last few years with the supply chain bottlenecks. So it's also important for us to grow the ecosystem. So there's many more suppliers in the market that actually is beneficial to the whole industry, right? And third, well, we have something that's working today, and we have to go productize it into an actual vehicle. And I think those are steps to me that once it is there, which we expect in the next couple of years to see this technology being driven in the new vehicles, I think the opportunities are limitless, right? So we think there's a great innovation here. There's a great market. There'll be many more zones that will be in the market. So the market opportunity is quite big as well. And that's what keeps us excited. And as market leaders, we are proud to bring these innovations to the industry and capitalize on it.
Well, it's going to be amazing when you look at what EVs look like, 2, 3, 4 years from now versus the EVs that are out right now. And, I've said this before, is that, we look at today's cars as they're driving computers. When you look at the innovations that you're bringing to market and just some of the capabilities that will be that you're going to be able to enable because of that real-time benefits to reducing latency, it's going to be a big deal. But I want to listen, Sandeep, thank you for participating in the podcast. Let me bring up one other slide here because I want to make sure people can get a hold of the information that we've just talked about. Again, thanks for taking the time to join me for today's podcast, Sandeep. For our viewing and listening audience, thanks for making the SmartTechCheck podcast part of your day or commute. Please make sure that you hit the like and subscribe buttons at the end of today's podcast, or use these on-screen QR codes to connect with me. You can also follow me on Twitter at @MarkVinaTechGuy. And until next time, have a great week. And Sandeep, thanks for dropping by in today's podcast.
Thank you, Mark. It was my pleasure.
Thanks very much.